Okay, well then we're almost done. Let me do one more example. The example is about negative powers. And I will do just one simple example. 1 over sine x dx. How to deal with that? Well, technically, it is a product of sine to some power of x times cosine to some power, cosine to the power 0, right? And the power of sine is -1, and -1 is a lucky number, which is odd. So you should be able to proceed with substitution, right? And what is the substitution that works for sine? Equals what? Should it be sine or cosine? Do you remember by now? It should be cosine. Then du is negative sine x dx. And then you can rewrite this as sine to the power -2 over x times sine x dx, when this becomes negative du. And that is simply, well, something about cosine, right? It is 1 over sine squared, and sine squared is 1 minus cosine squared. So it becomes 1 minus u squared, negative sign comes out, du. And now I got rid of the trigonometry at the cost of having a fraction. And we haven't learned how to integrate the fractions yet. And at this point, since you have this example in the homework, or may have, depending on randomization, you will have to do this, and I will show you the trick, but I will tell you the general rule of how to deal with fractions next week. So the trick here is to notice that this 1 over 1 minus u squared is equal to 1 over 1 plus u plus 1 over 1 minus u. Is that true? When you bring this to common denominator, what is that denominator going to be? It's the product, which is exactly 1 minus u squared, right? But when you do it, you will get 1 minus u there. So as I bring it to common denominator, 1 minus u squared, I will have 1 times 1 minus u plus that 1 times 1 plus u. And that u cancels. And 1 doesn't, and it becomes 2. So what I said was not true, but almost true. So that is equal to a half of that sum. Right? So in other words, 2 of those equals that. And then you should be able to integrate any of these two. You use logarithm. Well, you use a substitution, u plus 1 equals a new variable, and then 1 over that variable is logarithm. So the rest is very standard thing. Now, at this point, this formula looks like a trick for you. Use it for the homework, but next week I will tell you in general how to deal with the fractions. It will not become a trick, it will become a simple rule of how to deal with such things. So for today, the achievement is we are getting rid of trigonometry, regardless of what kind of powers you see there. Any questions?
Why did sine become to the -2nd power after you did the substitution?
Because I wanted one sine to become the part of du, and I borrowed it in the sense that I didn't have it. Right? I had only negative power. But to get sine, I have to multiply by sine and divide by sine.
Okay.
And that part, when I divide by sine, divides by one sine, and I already have one side divided by, so it will become divided by sine squared.
Divided by sine.
Right.
I understand.
Yeah, I'm not allowed to change the integrand